For this example, students in a physics classroom determined the resistance in an electrical circuit by measuring the voltage in V volts when a current in I amps was passed through the circuit. The table below shows the results. So the first thing is that I always need to know if my table is going horizontally, like this, then on the top is my horizontal axis, and on the bottom is my vertical axis. Why is this important? Because I'm going to need to say that this one is represented by I, and this one is represented by V. I also need to figure out what my scaling should be. Well, my horizontal value goes up to 4, but I have 5, 10, 15, 20, 25 lines. So in this case, logically, I'm going to say that it's every 5th line is going to be a point. My voltage goes up to 48, and here I have 5, 10, 15, 20, 25 lines, which means that if I want to go a little bit above 48, then I'm going to actually make every line here with 2, or I can write that as every 5th line is going to be 10. Remembering that I want to take up as much of the graph as possible. So then I'm going to find my points, where I'm going to start with the point of 0.5 amps and 6 volts. It's going to be in here. 1.5 amps and 18 volts. 3 amps and 36 volts, and 4 amps and 48 volts. In this case, when it says, does it make sense to join the points together with a straight line? Yes. The data is continuous. And partial points can be used. If I kept ramping up the amps, then it would give me all of these partial values in between here. And it would keep shooting off forever and ever and ever. So I'm going to include that little arrow at the end to say that the data will keep building up beyond the points of this graph. Now, if I am using the graph to determine the voltage for a current of 2.5 amps, then I'm going to go to the point of 2.5 for the amps. I'm going to go straight up from there, and then I can see that it hits at 2.5 and 30. if I'm writing an equation to represent V in terms of I, then I should see that if I'm checking these points, and I did it approximately, then for every 1 amp, there is 12 volts. How would I state that? The number of volts is equal to 12 times the number of amps. If I'm using the equation to determine the voltage when the current is 6.2 amps, then the voltage is going to equal 12 times 6.2, which means the voltage is going to be 74.4. If the resistance, or R ohms, is calculated from the equation, the voltage is equal to the amps times the ohms. State the resistance in this electrical circuit. Well, we can see from our equation that if voltage is equal to I times R, then the R value is equal to 12, and it's measured in ohms. Now, if we're talking about discrete versus continuous, the easiest way that I can explain it is that if it is continuous, then that means that both of the variables, the horizontal and the vertical, are going to be fluid values, which means that both of them have to be things that change gradually and can be used in partials. The most common ones for these are measurement changes gradually, time changes gradually, temperature changes gradually, volume changes gradually. Whereas if I was looking in terms of discrete values, it would be like, the number of students in my classroom, where either I have one student or I don't have the student in my classroom. I'm never going to have a point of 0.25 of a student in the classroom. So if one variable or the other is one that has to exist in exact values, whether that be whole numbers or whatever it happens to be, then I'm going to refer to that as discrete. So if it says time taken to complete a 100-meter sprint, the time changes gradually and the distance changes gradually. This is continuous. The number of students who pass M10C, well, I can only have exact numbers, and it has to be whole numbers, so this would be considered discrete. Now, C and D can get confusing. If I looked at it in terms of the heights of the students in class, that would be considered discrete. Each of you would have your own height. Whereas if I said, instead, the height of a student over time, that would be considered continuous. One of the other ones that confuses people quite frequently is the shoe size one. There's a difference between shoe size and foot size. Your foot size will change gradually. Your shoe size, like if you're trying to figure out, buying milk or whatever, you're buying it in exact increments that exist. There, are limited numbers of shoe sizes that exist, and you have to buy them, even though they can be in 7.5. It's either 7 or 7.5 or 8. There isn't a 7 3/4 or anything like that. So that would still be considered discrete. In order for it to be considered continuous, it would have to be able to exist as, theoretically, all real numbers that exist between the 2 points. All right, that is it. Go and try some practice.